Hello and a warm welcome. This is another Junior Taki production. I'm your host, Mr. T, and I'm proud to be presenting to you another lesson under the series on functions. In this specific video, we're going to be looking at a practice video. So let's get straight into the first question. We're given f of x is equals to x squared minus 2 and g of x is equals to 3 to the power x. The first question, 5.1.1, sketch the graph of f of x and g of x on the same set of axes, clearly indicate all intercepts on the graph. So to kickstart, we're going to start with the y-intercept of g of x. Now to get the y-intercept of g of x, we let x equal to 0. So we're going to have g of 0 is equals to 3 to the power 0. We know from our exponent that any number raised to the power 0 gives us 1. Therefore, the coordinate is actually 0 is to 1. We move on to the asymptote of G. So we want to find the asymptote of G. It's a case of just stating immediately that our Q value is 0, so our Y is equals to 0 becomes our asymptote. We proceed to finding the y-intercept of f of x. So we want to find the y-intercept of f of x. Same routine question. We're going to assume that x is 0. So if we get f of 0 is equals to negative 2. And therefore, in coordinate form, it's 0 is to minus 2. To get the x-intercept of f of x, we're going to make y equal to 0. So x-intercept of f of x, you make y equal to 0. So we get 0 is equals to x squared minus 2. Simplifying that quadratic equation or solving for x, we're going to say x squared is equals to 2. Finding the square root both sides, we get x value of plus or minus the square root of 2, representing our x-intercept. We move straight away to sketching the graph, starting with our axis and highlighting the main points that we need on that graph, which are seeing that we've got the two x-intercepts, we've got the y-intercepts as well. So let's start. I'm going to start off by just drawing the exponential graph here, g of x. That's the shape, including its asymptote, x is equals to 0. We move on to sketching the parabola, which is concave up because our value of a is positive. So it will be smiley, and this is the graph that we get. That's your f. Remember to label the graphs. If you've been asked to do it on the same set of axes, remember to label the graphs. We move on to 5.1.2. For 5.1.2, we're required to say for which value or values of x is the graph of g of x greater than 1. There are two ways of doing it. We can either use the graph or we can use algebraic methods. I'm going to use the algebraic method first, then I'll also use the graph to prove the same solution. So we start off by just substituting in place of g of x with 3 to the power x. So 3 to the power x is greater than 1, making sure that both sides of that inequality have the same bases. We get 3 to the power x is equals to 3 to the power 0, and therefore our final solution is x is greater than 0 as the required solution. So we want to prove the same solution, but now we want to do it graphically. Now to prove it graphically, you need to understand that if you are saying g of x is greater than 1, we know that the most important line is the line y is equals to 1, that dotted line in green, y is equals to 1. So we want to find for what values of x is the orange graph above that broken line. As you can see visually, that the most important part is that point over there. Starting from that point going to the right, we know that that graph would be above the broken line. And the x value, if you're going to read the x value there from the x-axis right there, it's literally at the origin. So x is greater than 0 straight away. So it's x is greater than 0. We proceed to the third question where we're required to find the range of f of x. Range assumes y values, and to get the range, remember, we always consider the lowest value of y, which is your q value. So for the range of that graph, we know that we're going to say the lowest value is minus 2. The lowest value is minus 2. So we're going to say our range is greater or equal to minus 2 and not plus 2. So it's minus 2. And also it's going to be minus 2 up to infinity. So it's negative 2, y greater or equal to minus 2, or y an element of minus 2 included up to infinity positive, unincluded. Moving on to the fourth question, 5.1.4. We're required to describe the transformation of f of x to h of x, given that h of x is x minus 2 times x plus 2. So to get that question, we're going to start off by manipulating. We start with our f of x, which is x squared minus 2, leading to the resulting function h of x as given. Then if we simplify the h of x, we're going to have x squared minus 2 leading to x squared minus 4. Important to see the highlights. I've highlighted the negative 2 and the negative 4 because that's the only change that you're seeing between the two functions. Therefore, you can see that that's just the q value, which has been subtracted by minus 2. Therefore, the conclusion is that if I'm to describe it in words, although I wasn't supposed to show you this working, but this was just to prove the calculation, you say f of x has been shifted 2 units down. That's the conclusion. That's the transformation. Moving on to the last question, 5.2. 5.2, you are told that determine the equation of the function g of x is equals to a over x plus q, and that's a hyperbola, with the asymptote y is equals negative 2. That's your q value. The straight line f of x is equals to negative x intersects the graph of g of x at the point 5 is to negative 5. That's the point of intersection, 5 is to negative 5. Starting point, we've already written the general equation of g of x. We then start with our q value, which is minus 2. So we write g of x is equals to a over x minus 2. Thereafter, we substitute the point 5 is to negative 5 into the same equation. If we do it correctly, we get negative 5 is equals to a over 5 minus 2. We're trying to solve for a, so we're going to move the negative 2 across. We remain with minus 3 is equals to a over 5. Therefore, we get an a value of negative 15. In conclusion, the equation can be written as g of x is equals to negative 15 over x minus 2. I hope you enjoyed that. Until next time, signing out has been Mr. T. Bye-bye.